Hello. Now we'll see next application of tunneling effect, which is tunnel diode. Normally you heard about different types of diode. Basic diode is PN junction diode. Now we just let's see how this diode is generally used by their doping and barrier potential. So doping and potential difference or potential barrier in normal PN junction diode is in the normal PN junction diode, doping level are of order 1 dopant atom in 10 raised to 8 atoms of intrinsic semiconductor. Means in 10 raised to 8 atoms, only a single atom in intrinsic semiconductor which is dope. Electron cannot move from N region to P region as deflection region act as potential barrier. So when potential barrier or when we are saying uh, the movement of electron and holes from one side to another side, they recombine and there is deflection region is formed, and due to that deflection region where that deflection region gets some potential barrier, and that potential barrier stops that recombination of electrons and holes. So that time electron cannot move from N region to P region due to these potential barrier. When an external potential difference is greater than potential barrier is applied, electron get sufficient energy to cross the potential barrier and conduction start. For example, if you connect external battery, that time that battery having potential greater than whatever the potential barrier. So when we applied that potential which is greater than potential barrier, that time electron moves from N region to P region when it has sufficient energy, and it crosses that deflection region which having that potential barrier, and that time conduction gets started. Means in short we are saying the current is passing through that diode. Now we'll see what happened in tunnel diode. First, let's see about the basic information of tunnel diode. The tunnel diode is also known as Isaki diode. It was invented by Leo Isaki and received Nobel Prize in physics for the same work. So again I'm repeating, the tunnel diode is invented or introduced by scientists. Scientist name is Leo Isaki, and for his work he got a Nobel Prize. Just see the symbol of this tunnel diode is similar to our diode. There is uh, anode and cathodes. Only this bracket like structure is there. In addition to that, simple simple diode symbol. This additional part is there. This is a symbol of tunnel diode. It is a PN junction device which exhibit negative resistance. The device is PN junction device which exhibit negative resistance. It means when potential difference across tunnel diode is increased, if potential difference across tunnel diode increase, current through it will be decreases. Clear? When potential difference across tunnel diode is increased, current through it will be decreased. See the p-type semiconductor and this n-type semiconductor, and the combination of that we are taking it is as tunnel diode. That time, though there is potential difference is there, still some electron from n side to p side is tunneling through that barrier. This tunneling by classically this is not possible, but but in quantum mechanically there is few chances that still that electron having less energy to cross this more barrier, there is small probability that that electron can tunnel through that potential barrier. The tunnel diode is capable to making very fast operation, and hence it is useful in micro frequency region. The tunnel diode having fast operation, hence it is used in micro frequency region. Now we'll see the principle of tunnel diode. In tunnel diode, P and N region are heavily doped of order of 1 dopant atom per 10 raised to 3 atom of intrinsic semiconductor. See the change here, 1 dopant atom per 10 raised to 3 atoms, while in normal diode there is 1 dopant atom per 10 raised to 8 atoms. The width of deflection layer is very narrow, which is of order of 10 raised to minus 8 meter. Again see, width of deflection layer is very small, and it is in order 10 raised to minus 8 meter. When very small potential difference is applied across the p-n junction, there is a direct flow of electron across the junctions, even when electrons do not having sufficient energy to cross the potential barrier of deflection region. See again, when very small potential difference is applied across the p-n junction, there is a direct flow of electron across the junctions, even when electrons do not have sufficient energy to cross potential barrier of deflection region. That is important point of tunneling effect. Though there is less energy, still that electron tunnel through potential barrier. The de Broglie wave quantum mechanically de Broglie waves are associated with electron. So that time we are not considering only particle nature of electron, we are considering wave nature also. So de Broglie waves gives combination equation of wave nature and particle nature. The wave function of electron has very small but definite value so that it can tunnel across the deflection region. What I'm saying, the wave function of electron has very small but definite value, and that definite value or the probability is always greater than 0, so that it can tunnel across the deflection region or potential barrier. Now we'll see advantages of tunnel diode. Different advantages again listed. The advantages of tunnel diodes are: first, very fast switching. When this switch on off is required in very fast scale, that time tunnel diode use. Then it having long life, so we can say it is more durable. Then high speed operation, for wherever high speed operation is required, that time tunnel diode is used. Then low noise, almost we can say there is near about zero noise. So when noise is less, it is more significant. Low power consumption, it required very small power. So we are saying low power consumption. Then we'll see different applications of tunnel diode, means in which field tunnel diode is used. First, we can note it one by one, but tunnel diodes used as logic memory storage devices. When high memory we have to save such devices, tunnel diodes are used. Then relaxation oscillator circuit, in oscillator relaxation, for the relaxation means time delays, these tunnel diode use. There is more detail you can see in electronics. Then ultra high speed switch means very high speed switches wherever required, that time it is used. And last, FM receivers, frequency modulator receivers, in that receivers these tunnel diodes are used. So in this part we have seen application, means it is tunneling diode. In tunnel diode there is a part which is in tunneling effect. There is a tunnel diode. In tunnel diode we have seen the basic things about tunnel diode, then the working principle, then advantage of tunnel diode, and applications of tunnel diode. Okay, thank you.